Look at a massive data center. It's easy to assume these machines instinctively know how to route data the moment they leave the factory. But underneath those blinking lights, a factory reset enterprise switch is essentially in a coma. It has no concept of what it is, where it lives on a network, or how to move a single byte of data. To demystify how devices actually learn to communicate, we are going to build a miniature network from absolute scratch. Our starting materials are 2 standard Windows PCs and 2 completely wiped Cisco Catalyst switches. We need standard Ethernet cables to create the network highways and a specialized console cable to communicate directly with the bare metal of the switches before the network even exists. By manually configuring every single rule, we strip away the illusion of plug-and-play convenience and expose the raw mechanical steps that power the internet. This diagram outlines our initial physical setup. We cable the 2 switches together in the center, and then connect PC A to switch 1 and PC B to switch 2. Right now, those Ethernet cables are completely useless. The devices are deaf and mute because they lack a logical map to navigate the physical copper. We start drawing that map at the endpoints. We assign a static IPv4 address of 192.168.1.10 to PC A and 192.168.1.11 to PC B. Notice this diagram, which breaks down the subnet mask applied to every device, 255.255.255.0. Think of those 255s as a locked zip code, strictly defining the first 3 sections of the IP address. The 0 at the end acts as an open door, allowing the final digits, like our 10 and 11, to identify individual computers. Because PC A and PC B share that identical mask, they perform a quick piece of binary math before sending any data. They check the destination IP, realize they share the same zip code, and know they can broadcast messages directly across the local switch without routing traffic out to the open internet. The physical cables dictate where the data can go, but this mathematical filter dictates exactly how the network behaves. Our computers have identities, but our switches are still blank slates. Plugging an Ethernet cable into them right now will accomplish nothing, because the switch does not know how to operate its own data ports. As you can see in this comparison, the standard network highway is closed. We have to use out-of-band management. By connecting our console cable directly into a dedicated management port on the switch, we bypass the network entirely and inject rules directly into the hardware's central nervous system. Using a terminal program on our PC, we enter the switch's global configuration mode. Our very first command assigns a unique host name, ensuring we know exactly which physical box we are altering in a rack full of identical machines. Next, we must disable automatic DNS lookups. Cisco operating systems have a quirk where a simple command line typo is interpreted as a request to find a server. Because we have no DNS servers built yet, one misspelled word will freeze the terminal for minutes while the switch searches for a server that does not exist. With our control session secured, we establish tiered security passwords. We assign a basic password for a technician to view the system status and a separate, strictly guarded password to execute structural changes. By defining a specific name, disabling search quirks, and locking down administrative access, we convert an empty metal box into an identifiable, controlled asset. Now we face a structural problem. A standard Layer 2 switch routes data based entirely on the physical hardware signatures of the devices plugged into it. It has no native understanding of the IP addresses we just assigned. This graphic illustrates our workaround. We generate a switch virtual interface within the software on VLAN 1. This acts as a simulated Layer 3 brain, giving our physical hardware a valid IP address, so we can manage it remotely over the network. Before we finish the configuration, we deploy a message of the day banner. This legal warning clearly establishes a boundary of trespassing for any unauthorized users attempting to access our hardware. Everything built so far currently exists only in the switch's volatile RAM, requiring continuous electrical current to survive. We execute the copy command to grab these active rules and burn them permanently into stable, non-volatile flash storage. Without that single command, a loose power cable or a tripped breaker would instantly erase all of our work, resetting the switch back to total amnesia. Our blueprint is fully written into the hardware. It is time to test the actual data paths. From the command prompt on PC A, we initiate a ping test targeted at the other computer and the network switches. When you hit enter, a tiny data packet shoots out of your PC and travels down the physical Ethernet wire. It hits the processor of the newly configured switch and demands a return signal. This terminal output is what we are looking for. Seeing 4 exact replies populating on the screen proves that our logical rules and our physical wiring are perfectly aligned. Checking the physical status of the switch reveals a final puzzle. Even with a perfect configuration, the vast majority of ports report as down. The interface will never lie about an open electrical circuit. No matter how thoroughly you program the software, a physical port will only register as active if an actual powered device is plugged into the other end. Today, artificial intelligence can push these exact configurations to thousands of data center servers in milliseconds. But underneath that automated speed, the internet still relies entirely on the precise alignment of physical cables, mathematically mapped boundaries, and carefully preserved memory.
Good morning, good afternoon, good evening. This is Professor Sistrom, and we have not another one, another lab. This particular lab is 2.9.2 lab basic switch and in-device configuration. Now, this lab is similar to the packet tracer that I did earlier, but remember, I'm doing all of the labs and packet tracers inside of packet tracer. At least I'm gonna try to do the majority of them like that. But what I want to show you is the reason I like these particular labs. When you get down here to the instructions part, it do not show you how to do anything. You have to remember, this is where we start going through, do I know the commands? So it asks you a particular question, or it gives you instructions on what to do, and you have to remember. So that's why I like these labs here. And that's what we're gonna be doing. We're gonna go into the phase now where we actually doing the work based off of what we know. Basic switch and in-device configuration. We're going to do network setup. And you know, in network setup, that's the topology. Of course, that lays out these particular 2 switches, 2 PCs, console cable, and Ethernet cable. And as you go to the addressing table, you see that it lays out what the IP addresses have to be. We got a VLAN, we got IP addresses for the PCs. So these are the things that you will be working through. And we want to make sure that you know how to do it. Of course, you know how to choose the right switches. We're not going to use Terraterm because all of the labs and packet tracers will be done on or inside of packet tracer. That's what we're going to do it. But we still going to hook up the console cable cord. So that will happen. As you can see with the PC configuration, you see we just going to put IP addresses on. We're going to verify settings. And you should know the commands to do these. So that should be fairly simple. Switch configuration table. When we come to the switch configuration table, we got basic settings, we got security, we got interface management. We showed you that on the last configuration, how to do that. And we're going to have the same thing with these particulars. This time we're going to put in the PCs because we want to make sure that the PC's passwords are put in. We're going to put in a course. We're going to put in a banner. We're going to do these particular things on this one. We're going to try to cover everything that we previously went through so we can make sure that we capture all of the commands that you should know now. And of course, in the verification of these particular commands, we always want to check our work. We want a command line verification. We want to make sure we check that particular work. And it says show running configuration, show version, show IP interface brief. You should know this now. Configuration storage. You pretty much know if you don't do copy running configuration, setup configuration, it will not store it. Now, did anybody notice I didn't do that in the last packet tracer that I did? I I wonder who paid attention. And right here, connectivity testing. We got right here in connectivity testing, we're just going to do ping. Ping, ping, ping. Ping the switch, ping the PCs. So this is our outline for today. Now, of course, you just watched the actual presentation. Now you see what we're going to walk through. And let's go in here and build out this packet tracer. Okay, now, so we just got through reviewing the video about this particular packet tracer. Now, remember, this packet tracer is similar to the one I previously completed. So let's go ahead and execute this packet tracer by starting off with my switches. I want to put the first switch here. Put that right there, and then I want to go ahead and put the second switch here. I'm actually going to change the name of this switch so it can say 2. This is purely cosmetic, people. It's not like I'm in there configuring the switches right now. So the next thing I want to do is give me a couple of PCs. So I'm going to put that PC there, put it right up under there, and then I'm going to come get the next PC and put that PC right here. Like I said, I want to do a little cosmetics here. Take that out and make that a 2. Okay, so there go the PCs, there go the switches. This is the first step. We want to go ahead and put on the console cables because we're going to configure these devices. And I'm going to put console cables over here too, so I can configure that. Then I'm going to go ahead and put the copper straight through cables in. I'm gonna come here and get that fast Ethernet, and then I'm gonna drop down to 6 here. Then I'm gonna come get the copper straight through and put it here for 1 fast Ethernet and 1 for fast Ethernet there. So there we go. We got that one there, and then I'm gonna come here and get the copper straight through here, and then I'm gonna go ahead and put it right there. But this time I'm gonna drop down to 18. Because I'm following the actual setup of the lab. I also want to go ahead and make sure my PCs are done. Now, if I put my mouse pointer over here, you will notice that nothing is really configured, but you can see that Fast Ethernet 1 is up and Fast Ethernet 6 is up over there. Okay, the VLAN at the bottom, as you can see, it has nothing set up. I'm gonna come over here and do the same thing. Fast Ethernet 1 is up, and then you see Fast Ethernet 18 is up. VLAN is not up. Now, what I wanna do now is just go ahead and get my PCs in order. So I'm gonna come over here and put the IP address for my PCs in. This is gonna be 192.168.1, and this is the first PC, so that's going to be 10. So we have that. Now, I showed you this earlier. I'm going to copy this just to hide it, and I'm going to tab to get my subnet mask in. Close that out and go do the next PC the same way. You will get better, you will get faster at doing this. As you can see, I'm moving pretty quick to get this done. So you will be the same way. The more you practice, the better you are. As one individual said a long time ago, lab up. So there you go. Now, if I hover my mouse pointer over the PCs, you can see that PC Fast Ethernet 0 is up and it has an IP address attached to it. If I do the same thing over here, Fast Ethernet 0 is up and an IP address on there, and that's 10. Okay, so we're doing real good. Now, let's go in here and do some configuration on the switch. Now, a lot of things I'm not going to do, but it's things that I have to do. So, as you can see right here, I want to do just a show. I'm going to go ahead and quickly and do a show version, because that lets you know what application you are working with. Okay, so there we go right there. Okay, so you see that. Now I'm gonna go ahead and do enable to get in here, escalate myself up, and I'm gonna go ahead and throw the clock on here, because remember, the clock is one of the things that we were doing in other. And I want to keep these skills. I want you to remember, do not lose your skills. So I got clock set 1500, and I'm gonna go October, and I'm gonna put in 26, and I'm gonna say 2026. I'm just putting a clock set in there. No special date or anything. I just want to make sure it's in there. So we put the clock in there. Then I'm gonna do config and T, and then I'm gonna go put a banner in. Remember, this is another command that you learned how to put banners in. So I'm gonna go ahead and throw that banner in there, and I'm gonna keep it simple by just putting anything in there. But you know what's the purpose of the banner. If you don't know, go back and watch my videos, even in this video. So you can see that the banner is in there now. Now I'm gonna change the name of this. Since I'm already in configuration mode, I'm gonna just say host S1, and I'm gonna hit enter, and then I'm gonna go exit. I'm gonna exit. Let me go back. I messed up again. Okay, so that takes me out. Okay, now if I say show run, you should be able to see that particular information. So let's bring it up here so we can get close to where we actually executed that at. And you can see right here, I have here is show run, and then we got the name we just changed. And what else did we make a change on? We got the banner in there, but we don't have a VLAN. So let's go ahead and put the VLAN in there. So we're gonna say config T, and we're gonna say enter VLAN 1. That's interface VLAN 1, and we're gonna put IP address, and we're gonna put in the IP address for VLAN 1, which would be 192.168.1.1. If we did that right, it should be that. Now we gotta make sure we finish the subnet mask 255.255.255.0. That should be correct. We hit enter, and then we say show. We're not finished. We gotta go no shutdown. Remember that, no shutdown. Now you see the line is change state to up. So this is important. Remember, it was this right here, it was down. Now we changed it to up. VLAN interface 1 is up. Okay, so we have our VLANs in. Now I'm not gonna put the passwords and stuff in there because that's really not something we wanna do right now anyway, and it'll slow us down. So we got our VLAN in there. So what I'm gonna do is simply exit, and I'm gonna exit here too. But I'm gonna put another command in there where it's called show. I wanna go ahead and, you know what I'm gonna do? I'm gonna save this. I'm gonna go copy, run, start up. Okay, now reason I'm putting that in is because I wanna save the configuration. If you remember in my last video, I did not do that. How many people were paying attention to that last video? I don't know, you should have caught that. Okay, now I can say show, now I want to just say, I want to go say show IP interface, and I want to put brief. Now, as you can see right here, let's go ahead and do it all so we can see it all. You see right here, I have Fast Ethernet 0 up. Okay, I say Fast Ethernet 06 up. And now I got a VLAN on here. So this is working perfectly, and the configuration is saved. So that is great. So let's go ahead and close that. And now let's go do the same thing over here. We're going to go to the terminal, the connection, and enable. And we're just going to go straight in and make the changes to this. We're not going to put the clock in and all that. We don't have to do all that. We just want to right now do config T. Then we want to go interface. We want to begin to just go ahead and put the VLAN on there. VLAN 1, okay. And then we're going to put the IP address in here, right? Just like we did that other one. And it's just to make sure we make the connection, basically. So I'm going to go 192.168.1.2, because this is the 2, and we want to go 255.255.255.0. Okay, if that works, we're good. And we want to say no. Take that out. No. Checked. Okay, the line is up. Okay, now I'm going to change this. I'm going to go exit. And I'm going to go S2. Okay, so I changed the name. So I did that successfully. What else? So pretty much I'm gonna leave this just like this because we able to communicate. Now I'm gonna go ahead and save it. I'm gonna go to exit, and I'm gonna say copy, run to start up. Want to make sure we get that in absolutely correct, because if we don't, we will have some serious problems. What did I say? Copy, run, start up. That's in there. What else did I want to do? So I actually saved the configuration. I do want to go show IP interface. In this show IP interface, I may have said it, I may not. It's just looking at the interfaces, that the lines that you have up. Okay, and that's what we did. We see our VLAN right here. We see this is connected here, and that's up too. So the lines are up. So now what I want to do is I'm gonna close this out. I didn't do as much over here as I did here because you pretty much get it here. I can go do some other stuff, but I want to make sure I keep these as short as possible. I'm actually going to go and do a ping now. So I am going to ping the switch first. I'm going to go 1 and 2.168.1.2. So this is switch 2, and I'm going to hit enter. If that's correct, I should have one error because it's reaching out, and the rest should fall in order. Let's see if that happened. That's correct. It's okay. If I do it again, I shouldn't have any errors. Now I want to go hit the PC, and this PC is 11. There we go. Let's see if that's correct. And that is. So we did a brief to make sure they was up. We did a ping to catch them. And that's basically it for this particular lab setup. So I think this is everything. Now, of course, I could have put in here passwords and all that. You already got that down. I could have put in here, everything else was done. It was just the passwords that I put in because I didn't want it to slow me down. I'm gonna look over my particular document to see if it's anything else, and no, that's it. So we completed this task successfully. With that being said, this is Professor Sistrunk, and I'll see you in the next video.